Okay, this video accompanies our student companion. The first part of this is the critique and explain. Now, we went through this in the presentation page, but let's just kind of review this a little bit. Again, like what William has done here is a two-column proof. We have statement columns, or a statement column, and a reason column. And these steps should be numbered, basically to keep things lined up and in order. And he decided, let's kind of read our way through the proof, see what he did here. So his problem was to solve 6 times the quantity 14 plus x is equal to 108. And he used the distributive property first. He did 6 times 14 and 6 times x equal to 108. Then he subtracted 84 from both sides. Then he simplified. 108 take away 84 is 24. And then he multiplied both sides by 1 over 6 to get, and 24 over 6 comes out to be 4. So that's pretty much the process that he used, and it looks like his justifications are valid. So nothing to change there. Another series of steps that could result in the same solution would be, let's see, what if we divided first instead of using the distributive property and simplified the numbers that way? So we got our statement reason. Our initial problem, 6 times x plus 14 equals 108. It's our given. I'm going to divide both sides by 6. So x plus 14 equals 18. 108 divided by 6 is 18. That would be division property of equality. And step 3, subtract 14 from both. Well, let's look at it this way. I'm going to add a negative 14 to both sides. I'm looking at it as I'm going to do the reciprocal. Opposite of addition is to add a negative. I'm going to add a negative 14 on the left. I'm going to add a negative 14 on the right. I'm going to end up with x is equal to 4. But my thinking behind that was that I added a negative 14 to both sides. So I actually use the addition property of equality. Now, if I looked at it as subtracting 14 from both sides, my reason would have been subtraction property of equality. So the steps that you use as your supporting reason, well, the supporting reasons you use for your steps should follow what your reasoning was as you completed those steps. So if I'm looking at it as adding the opposite, it's an addition property. If I looked at it as subtracting 14, then I would have put subtraction property of equality. Okay. Let's look at the example 1, try it. We want to complete this 2-column proof. Let me blow this up a little bit. So we want to do this 2-column proof. So we always start with a statement reason, column, set of columns. We have this like T pattern here. We're going to start with our given, BD bisects angle CBE. Now, before we move on, we have to kind of think our way through this and come up with a plan. So our 4 problem-solving step process comes in. First step, understanding, like you read the problem, ask yourself what they're asking you to do. They want us to prove that ABD, this angle, is congruent to this angle CB, is congruent to angle FBD. They want us to prove that these two angles are congruent to each other. So in looking at this, we can kind of see that ABC and FBE are going to be congruent because those are vertical angles. And if this ray is a bisector, then this angle CBE is divided into two congruent angles. So angle CBD and angle EBD are the same, since the bisector makes two congruent angles. And we have, for ABD angle, we have ABC plus CBD is going to equal ABD. And for our FBD angle, we have that as FBE plus EBD equals the FBD angle. And we've got two vertical angles added to two other congruent angles. When we add those, or two vertical angles added with, the other angles, we can see that you're adding equals to equals. The results are going to be equals. So that's what's going on with this proof. So let's see how we can do this. Now there's, the way you go through these kind of depends on what you're thinking. We got the bisector as our given. So maybe what I want to do for the second step here is note that this bisector makes these two congruent angles. So I could say the measure of angle CBD is equal to the measure of angle EBD. And this would be definition of angle bisector. An angle bisector makes two equal angles out of one. Okay, so if the measure of these two are equal to each other, let's see what we got now. ABC and FBE are vertical angles. So maybe I want to note that. Angle ABC, comma, angle FBE are vertical angles. That's my abbreviation for angles. And that would be definition of vertical angles. Now, since those are vertical angles, by our vertical angles theorem, we have that the measure of angle ABC is equal to the measure of angle FBE. And that would be our vertical angles theorem. So if we look, we've got ABC. Let me clear the markings up on this. Let's see what. Another good habit when you're doing a proof is, as you do the proof, and this works really well if you're using pencil, you want to mark up the diagram with what you've brought out. So we've got that CBD is equal to EBD. So CBD and EBD are congruent. We got that from step 2. And then from step 4, we have that the measure of ABC is equal to the measure of FBE. That was our vertical angles theorem. So we can see what's going on with this now. Like this one plus this one is equal to this one plus this one, and it leaves the big angles equal to each other, which is what we want to prove. So let's see what our step 5 should be then. Using steps 2 and 4, I'm going to add the left-hand sides together, and then I'm going to add the right-hand sides together. And that would be addition property of equality. So I've got the measure of angle CBD plus the measure of angle ABC is equal to the measure of angle EBD plus the measure of angle FBE. And that's really just addition property of equality. I'm adding equals on to both parts. So there's our step 5. Now, CBD, let's see, the measure of angle CBD plus the measure of angle ABC is equal to the measure of angle ABD. So we could say for step 6, the measure of angle CBD plus measure of angle ABC equals measure of angle ABD. Also, the measure of angle EBD added with the measure of angle FBE equals the measure of angle FBD. And that is angle addition postulate. Notice that angle addition postulate is used. A postulate is like a theorem, but a postulate isn't proved. It's just accepted as being so. So that's our angle addition postulate. It says we can add two angles together and the resulting angle is going to be the sum of the two angle measures. That's our angle addition postulate. So now we're going to use 6 and 5 together. And so let me go back and clarify this a little bit more. So what we did here with step 5 was we used steps 2 and steps 4 together. So I might want to maybe note that I used steps 2 and 4 for number 5 when I did the angle addition postulate, and for the addition property of equality. And then for step 6, we're just basically noting that this is angle addition. These make the big angle. Step 7, though, we're going to combine these together, since in step 5, CBD and ABC is equal to EBD and FBE. We have a substitution that we can do. CBD and ABC is the same thing as ABD, and EBD and FBE are the same thing as FBD, so I'm going to substitute those in together. So in step 7, I'm going to say that the measure of angle ABD is equal to the measure of angle FBD. And that's substitution, property of equality. Now, what steps did I use for that? I basically used step 6 with step 5. So I'm just, for myself, making a note of what I did there. It might help clarify something. Oh, substitution, what the heck? And then you say, oh, 5 and 6. Okay, now they can focus on 5 and 6 and see, now where did how is this a substitution? And they can figure out what you did. Same thing up here. How do they use addition property of equality? Well, they use 2 and 4 together. So it's not obvious. It's helpful to make a note off to the side. That might be good in the future if you need to go back and figure out how you did something or explain how you did it. Now, we're basically done with this now. Since the measure of ABD is equal to the measure of FBD, we can say that by definition of congruence, that angle ABD must be congruent to angle FBD. And that would be definition of congruent angles. And we've basically ended up with what we needed to prove. So we're done with that one. Let's move on. Okay, our example 2, we want to apply the vertical angles theorem. So here we have some algebra problems to do. Since we have pairs of vertical angles here, they're telling us that the left-hand angle is 6x minus 45. We'll call this angle 1. And we have that the right-hand angle is 4x plus 5. Well, by the vertical angles theorem, these angles are congruent, which means their measures are equal. So the measure of angle 1 is equal to the measure of angle 2. Now the measure of angle 1, so this is pretty much our vertical angles theorem. If I was doing this as a two-column proof, that would be my reason. Measure angle 1 equal measure angle 2, reason, vertical angles theorem. Also, our given is that the measure of angle 1 is 6x minus 45, and the measure of angle 2 is 4x plus 5. So that would be a given step. Then I would substitute in 6x minus 45 for the measure of angle 1. That would be substitution property equality. And that's equal to 4x plus 5, which is substituted in for 2. Sets those equal to each other. And now I would solve for x. I would take away 4x from both sides. We'd call that subtraction property equality. And then I would add 45 to both sides. We would end up with 2x's is equal to 50. That would be addition property equality. Then I would say divide both sides by 2. I would have x is equal to 25. And that would be division property equality. And they want us to find out what the measure of x was. Got that. But also, now this is where the looking back comes in. We got done, look back, reread the problem. They also want us to find the measure of each labeled angle. If x is 25, then each one, since these angles are congruent, the easiest one to do would be to plug 25 into number 2. 4 times 25 is 100, plus 5 makes 105. So the measure of angle 1 equals the measure of angle 2 equals 105 degrees. So that's what we would do for A. Let's look at B now. B, we have another set of vertical angles. These angles are congruent because of the vertical angles theorem, which means we can set their algebraic expressions equal to each other. So we've got 8x minus 20 has to be equal to 5x plus 37. I would add 20 to both sides, so 8x equals 5x plus 57. Now, if I needed a supporting reason, the first one would be given. The second one would be addition property of equality. Now I need to take away 5x from both sides to get x's on the left. So I've got 3x's is equal to 57. That would be subtraction property of equality. And then let's say to simplify this, I'm going to multiply both sides by the reciprocal of 3. I'm going to multiply both sides by 1/3. So I get x is equal to 57 divided by 3, which is 19. And that would be multiplication property of equality. If I looked at it as multiplying by 1/3, if I divided both sides by 3, which is the same thing, I would get, my reason would be division property of equality. So we get x is equal to 19. So if x is equal to 19, we want to plug it in. Probably the easiest one would probably be the one on the right. 5 times 19 is going to be 50 plus 45 is going to be 95. And 95 and 37. 95 and 30 is going to be 125. And another 7 makes 132. So the measure of angle 3 is equal to the measure of angle 4, which is equal to 132 degrees. Okay, let's move on. We're not going to do a paragraph proof right now, so we'll skip this one. Basically, you need to have a logical argument. 1 and 2 are complementary, 2 and 3 are complementary. Congruent complements says that angle 1 must be congruent to angle 3. So that would basically be the argument. Like we'd say, well, since angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, since angle 2 is congruent to itself, by the congruent complements theorem, it must be so that angle 1 is congruent to angle 3. That would be the paragraph type argument. So look at example 4. Well, I'm ready to column proof for this. So let's, we got our diagram. So let's do our statement using column. And let's kind of think about this now and come up with a plan. So the understanding is, what do we need to do here? We need to basically prove that measure angle 3 is equal to 70. And what are we given? We're given that 4 is equal to 35. And we're given that 1 is equal to 2, which means this is angle bisector. And, is angle 2 plus angle 4. 1 is equal to 2 plus 4. So these two together add up to be angle 1. So this is not an angle bisector. And so let's see what we have here. How can we do this? Let me get this out of the way. So angle 1 and angle 3 are vertical angles. If angle 4 is 35, that means angle 2 must be 35 because those are vertical angles. And angle 1 is congruent to angle 3. And angle 3 and angle 1 are congruent because those are vertical angles. So if we look at 2 and 1, let's see what we got here. Get this out of the way. So notice I'm not exactly sure where exactly to go with this yet, but I know that we need to start with our givens. So I'm going to throw those in there. So the measure of angle 4 is 35. I'm going to label it. The measure of angle 1 is equal to 2 plus 4. Now, by vertical angles, angle 2 is going to be 35 degrees. So 1 is going to be 35 plus 35. 1 is going to be 70 degrees. And then by vertical angles, 3 is going to be 70 degrees. So that's the way this proof is going to need to go. We're going to use measure of angle 1 is equal to 2 plus 4. But 2 and 4 are the same because those are vertical angles. So 1 is going to end up being 70 degrees, and then by vertical angles, 3 has to be 70 degrees. So that's what we kind of need to bring out in the proof to end up with angle 3 equal to 70 degrees. So I didn't see it to start with, but now I feel a little bit more comfortable about the path we need to go through. So I'm just going to put angle 4 is equal to 35 degrees. That's given. And we still got this one that we can use as we need it. But for step 2, I'm going to say that angle 4 and angle 2 are vertical angles. I'm going to use V period A period as vertical angles. And that's definition of vertical angles. Vertical angles, VA. That lets me say that they're equal to each other. So the measure of angle 4 is equal to the measure of angle 2, and that's because of the vertical angles theorem, VA theorem. So I've got 4 and 2 are equal to each other. And also they're both 35 degrees. Okay, now I want to bring in the other part of our given. Measure of angle 1 equals measure of angle 2 plus measure angle 4. That's given. Notice I didn't have to do it first. Sometimes I could have put it all in the first step, but sometimes it's more straightforward if you bring them in like a logical order as you need to use them. So we got, so that's letting us know then that, also we have that angle 4 is 35. And since 4 is equal to 2, we could say that angle 2 is 35. We're going to need to get that. So we have measure angle 2 equals 35. So since the measure of angle 4 is equal to the measure of angle 2, and the measure of angle 4 is 35, we have that the measure of angle 2 must be 35. Now this is transitive property. We've got that 4 is equal to 35. Or is it transitive property? We have 4 is equal to 35. No, but 4 is equal to 2. Yeah, so that's transitive property. So the 4 hooks these together and leaves angle 2 equal to 35 degrees. So that's going to be transitive. Could also be substitution if you look at it a little bit differently. So measure of angle 2 is 35. So we've got 2 and 4 together makes angle 1. So in step 6, the measure of angle 1 equals 70. And that's really substituting. Well, I really did 2 steps there. I substituted and simplified. But I substituted 35 in for 2. I substituted 35 in for 4. Both of those together add up to be 70, leaves angle 1 equal to 70. So I'm going to call it substitution. And I used, let's see, step 5. And I used step 4. And I also used step 1. So I'm making a note for myself of how I did the substitution. I used 4b and 35 from step 1. I used 2b and 35 from step 5. And I used that 1 was equal to 2 plus 4 in step 4, which left me with the 70 degrees. So I kind of combined a couple steps there. But we got measure of angle 1 is equal to 70. Now let's note that angle 1 and angle 3 are vertical angles. Angle 1, angle 3 are vertical angles. That's the definition of vertical angles. And since those are vertical angles, they must be equal to each other. So the measure of angle 1 equals the measure of angle 3. That's our vertical angles theorem. Now, since 1 is congruent to 3, and the measure of angle 3 is, let's see if we can, since the measure of angle 1 is 70 in step 6, we can substitute 70 in for the measure of angle 1 in step 8. So our step 9 is going to say that 70 is equal to the measure of angle 3. And that is substitution. Property of equality. And what steps did I use for that? I used 6 and 8. So I've got 70 is equal to the measure of angle 3. I'm almost done, but notice that they want us to end up with measure of angle 3 is equal to 70. I've got this flipped around, so I need to use the symmetric property and put measure of angle 3 on the left. So measure of angle 3 is equal to 70, and that last step is symmetric property of equality. Lets me spin it around the equal sign. If there was a congruent sign there, it would be symmetric property of congruence. So we were asked to prove that measure of angle 3 is equal to 70. We did that. I checked it. Seems like logical steps to me. And we're done. Let's move on. Okay, here's the do you understand, do you know hows. These are the ones you need to do on your own. So remember, this is 8 points. You're going to need to do this one on your own. We can go over this in class. If you have questions, ask. And we're done with the try-its on the student companion.